Hi, in this video, I'm going to talk about drawing images on parts of the user interface. There are different ways of doing this. You can also add like icon type images to buttons, but I'm going to talk about just sort of drawing in general on things like panels. So, as a little review, we have our JFrame as the outermost container, the top level window of an application. Then we have containers like JPanel that hold components and other containers, and you have their arrangement specified with a layout. And again, you can have a hierarchy of these things so that one JPanel holds another JPanel, and that JPanel holds a bunch of buttons, and there's a layout for that one, and a layout for the other panel, and it all gets a little complicated. And then there are components that are the things we interact with, and essentially normally those we have a listener either for the specific component or for the overall panel or JFrame, and we add listeners to respond to actions. And in that action listener or method is where sort of the logic of making changes to the interface happens. So what I want to do here is have us, you've probably seen those flip books where you have a series of images and you flip through it and it makes sort of an animation. So I'd like to draw a series of images on a panel. So the question is, okay, so that's the goal. And again, what we've been practicing in this class is thinking about how to solve a problem. You're given a short statement like that. Draw a series of images on a panel. And by series of images, I mean like one after the other in time, not like lined up in position. So you have to think about what do we need to do to solve this problem? Well, you need to figure out how to get a image in the program. So we need how do we load an image, and Java Swing probably uses something different than we've used earlier in the course, so that picture class, but it's probably related to it. It has the same kind of stuff associated with it. We need to somehow store several of these images, and we need to draw the image on a user interface. So if we can figure out those things, then we can figure out how to do the overall problem. So some of it takes some Googling, of course. You look around Java Swing, how do I display an image? And these big systems, there also tends to be a few options, and you have to kind of figure out what the best one for your needs are. Oops, what did I just do? Get rid of that. That was weird. So, this comes up a lot, drawing images, medical applications, games, animations, icons, and so on. And through a little Googling, Java has an image superclass, in other words, sort of a more abstract kind of image class that other things can build on. And then it has something called buffered image that code can kind of directly work with. And so, again, I Googled around and I saw some stuff that says, here's how you load a buffered image and here's how you, do stuff to it. So that seems kind of promising. Okay, so that's, maybe what we need to do for this. Let me hold on a second. Okay, my cursor is always disappearing, which is odd. So we know how to load an image. Now storing several images. How would you do that? Well, luckily that's pretty straightforward, right? We need an array of some kind, and maybe it'd be nice to use an array list of these buffered images. And then we need to draw the image on the UI, and that's the part that I want to talk about in a little detail here. So, so the question is, first of all, when do you need to draw something on the screen? Well, one is when we want it to be drawn, but maybe there's other situations where you need to redraw what your user interface looks like. For example, if you change the window, everything moves around, and to move around, you have to kind of redraw it, basically. Maybe when some event happens, so those events might change the window in some way, and so you need to redraw it. Maybe you have covered your window with something else, and then when you remove it, you have to draw it again so it shows up again. And so those are all things that the system kind of does for us, but they all involve drawing the window. But we can also force, or really ask, force is too strong, ask the application to redraw itself. And there's a repaint call that says, hey, when you get a moment, please redraw yourself, or basically as soon as possible. So what does this repaint do? Well, repaint basically calls the paint method of the component, and the paint method calls paint component, paint border, and paint children. So basically, um, there's a part that draws like the main part of it, and there's a part that draws it around it, and then there's a part that draws anything attached to it. And so, there's layers here, right? And you have to kind of trace your way through it. Now, what do we need to do? We need to override the paint component method and say how we want this thing to look like. Okay, so let's think about this. So how does this work? How does overriding some what looks like sort of random method suddenly hook us into this larger system of getting painted, of getting redrawn? And really, in all these things, I sort of say like, hey, here is this action listener. If you write it, then it will respond to events. And I say, hey, here's this paint component method. If you write it, you can draw what you want on your component, right? Why? Why does that work? Okay, so it's all through this inheritance and polymorphism. So somewhere there's code that looks like for, well, container or maybe component C out of some list of known containers or components, C paint. All right? And that C paint calls the C paint component. Now, since image panel, which is the thing we're going to write, this image flip thing, inherits from container, since we inherit from JPanel, it will use whatever standard paint and standard paint component is there already, unless we provide our own method to override it. So it's not like we are creating this method and it only exists by itself. It is actually overriding some other method with the same name that will get called unless we provide a new functionality in our own method. Okay, so all those things basically then say, hey, there's a default to use, but if you want to provide your own more specific function, then functionality, then go ahead and give it the same name, override it, and it will get called instead of the one higher up the inheritance chain. Okay, so again, it's not that we're just sort of writing a method and it just sort of makes things work. It is being called, and either it's being called with a default or it's being called with the one we provide. Okay, so just somewhere there's a very abstract list of stuff that gets called, and our thing is part of that list. And then when it calls this, it somehow figures out that we have our own paint component, and that's what gets drawn. Okay, so it's still complicated for sure, but it's not magic, right? It's part of a whole structure, and that's what's sort of interesting, I think, with this inheritance code is that you can belong to these whole structures, and you provide some little change, and you get sort of this nice specific functionality. Now, so we do want to override this paint component, and there's two parts. One is we call the paint component for the thing we inherit from, like JPanel, and that basically makes it look like a normal panel. Maybe it has a border and all that kind of stuff. And then we do a little extra. So there's this draw image, and we give the image, the buffered image here, and we give sort of a starting point and a size. Okay. If you just Google like how do I draw something on Java Swing, half the advice is wrong basically, and it'll kind of work, but it won't work very well. It will ask you from your panel to get some graphics thing, and then to draw your image using that graphics. But it doesn't happen at the right time basically. That's the hard thing. So if you hook into the normal system for repainting, then it will work when it's supposed to work. Otherwise, it's sort of up to you to manage all of it. Okay, so we're going to make a image panel class. We're going to inherit from JPanel. We're going to add an image to it as an instance variable, and then override this paint component to draw it, and then use it in some JFrame application. Okay, so let's write some code. Okay, so we have image panel, and we want to extend JPanel, and that's because this is going to be a kind of a panel, right? Something that is just a chunk of space for stuff to other stuff to go on. And we don't know about JPanel, so we're going to import JPanel. And like I said, I'm not sure I totally approve of this, but we're going to import all of the Swing stuff to maybe speed up this issue a little bit. We need a constructor for image panel. Well, let's first, okay, so what is an image panel going to do? It wants to draw an image on itself. And so we need one of these things. We have a private instance variable that is a buffered image, and I'm just going to call that image. This is not part of Swing, it's part of some other stuff, this AWT image thing, so I have to import that. Okay, so now we have image here. I'm going to make my public constructor, and it is going to take in a buffered image. Buffered image. 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 Good enough. And I'm going to assign that, well, this dot image equals image. So I've taken the parameter image and assigned it to the instance variable, so it sticks around after we're done with the constructor. And I'm going to set the size of the panel to match that of the image. So I'm going to set the preferred size to be, we did a little of this in the lab, right? New dimension, image.getWidth, and again I had to look up what are the getters for the size of the image. Oh, image. In my example code that I'm just gonna have off to the side here, I just say img, and I'm gonna keep probably confusing that unless I get consistent here. So image get width, image get height, and we don't know what a dimension is. Again, there's so much importing when you're doing the GUI stuff. Okay, in some ways, this is what the panel information and setup has to be, right? The panel is this big and it holds an image inside it. Let's start making our application so we can start kind of figuring out what this is all going to look like. So I need to make an app with a JFrame. So JFrame frame equals new JFrame, and I can give it a little title, right? Flipbook. And I need to set default close operation, JFrame exit on close. And again, normally I would just copy and paste that from another earlier example code I have. So now we got to load the image here. Image, and that's going to use sort of like a reading on a file kind of thing with a try catch. So I'm going to make a buffered image, image1, and I'm going to do a try. Well, let's force it to be wrong first and let the quick fix happen. So I'm going to say image1 equals image IO, and again, I just went and, there's some tutorial that showed me how to load a buffered image. You're not better off reading like exactly what a buffered image is and reading all the methods it has and reading all the, that kind of stuff. What you want is a little chunk of code that tells you how to read a buffered image. And so I looked around until I basically see that. And that's perfectly fine, right? Learning to do some little tiny thing that is like one step in this whole process is perfectly fine to go look on the internet for this kind of stuff. Lecture 32. And I've loaded in a picture of myself. It's in the package right now. All right, and we got to import a file. And we got to import image IO. Okay, so I'm trying to read from this new file that is the file name inside here and use it to read this, and it is complaining I need a try catch around it. Boom, boom, boom. Okay. And I should clean this up a little bit, right? But basically, if I manage to read the file, this is no longer null, and we're ready to go. Since I know it's going to work at this point, I'm not going to try to add some stuff where I quit or redo it or whatever. I'm just going to kind of carry on. Okay, so I'm going to make an image panel. Panel equals a new. So this is the class I'm writing, right? New image panel. This is a panel apparently that can draw an image on itself. I had to provide the image as the argument to this constructor. So I'm going to pass in image1. And I need to add the panel to the frame. And then I need to pack the frame around all the components that I've added. And I need to show the J-frame. Phew. Okay, somehow we end up with all these lines. I just like to hit return, I guess, at various times. Okay, so what are we doing here? We made a frame. We told it to quit the program when we click the red close thing on the window. We did our complicated stuff to read the image from this file. And then I added that buffered image to the custom panel that I'm making. And then added this custom panel to the frame and made it show itself. All right, if I run this, I'm going to get some behavior. I guess I should have made my recording a little bit bigger because my image is going to be bigger than this. So look, the frame, the flipbook thing is big, so the image is probably something big, but it's not showing anything, right? And that is because I have not told it how to use the image when it gets painted. So I have a constructor here, but I did not override the paint component method. All right, and again, this is something I had to sort of look at as an example. Like, what is this paint component method? Well, it is a public void paint component, and I actually think there is a paint components as well, but that's the wrong one to override, and it's sort of a common error to choose that one. So just be careful when you're doing that. And this thing takes in, again, not from us, but from that upper system that's looping over all these components and saying to paint itself, this graphics object thing that we don't really have to know what it is, to be honest. All right? Except if the code has to know what it is, so we got to import it. Import. Okay. And again, the process is first we tell it to do the normal behavior for the thing we're inheriting from. So super paint component, and again we have to pass in this graphics object. We're just going to pass it upstream to that thing, and then we're going to tell it to draw this image on this graphics object. Draw image, and we use the image that we've stored in the JPanel image, and then we say start in the corner, 0 x0 y0, and then we have to pass our current object in for some reason that, we're just following the pattern here, basically. Okay, maybe that's all there is. So we found this draw image. Again, some small tutorial that said, how do you draw a buffered image on a panel? You draw, you draw on the graphics component of it, draw an image like this. And now you just have to follow that pattern yourself. Okay, so I draw it. All right. Is that me? Doesn't look too much like me. No. It's me. Okay, so here we have a single image. This is not much of a flip book. It is a single image. So we need to have at least 2 images so we can flip back and forth between them. Okay, so let's go down here and read a second image. So I have image 1 and image 2. And here I'm going to do in the same try catch. I could do them in separate try catches, but if one of these fails, we need to do something about it. And I have me and me too. And I want to pass both of these into the image panel, but of course I haven't set it up to accept that yet. So up here, I have also another buffered image, and let's make that image 1 and image 2. And here, I could store, 2 images up here, and then have something to flip between the 2 of them. Let's just make it a little more general right off the bat, and we're going to make this an array list of buffered image. And this will be images now. And I need to keep track of which image I'm looking at with an index. And then I need to set that all up in here. So we no longer have one image, we now have an array list of images, and we have to kind of change all our code to work with this array list instead of a single image. So first of all, I need to take images and make a new empty array list out of that. And I've noticed some of you were doing this without including the little generics diamond there. And that does something, but it's not really doing the right thing. It's a little dangerous. So either really put the type in here, or you can leave it blank because it can infer it from the type here, but don't not include it all together. Okay, so I have, what's it complaining about? Array list cannot be resolved to a type. Import that. Okay. Then to images, oops, I'm going to add image 1, and I'm going to add image 2. Get rid of that. I'm assuming these are the same size. That's maybe not, fully generalized, but I'm going to set this to the size of the first image. Okay, so now we have an array list of images. Down here, we need to draw the images that we're going to get from the image index. Notice this is default initialized to 0. If I wanted something different, I could set it in here, right? Okay, so now we sort of haven't really done anything yet, except we're still always drawing the 0 image, but it's good to see that I can at least get something up here. Okay, promising. Let's say after we draw the current image, I want to set the image index ++. Now, that would work for a moment, but we're going to go 0, 1, 2, 3, 4, and we're going to get an index out of bounds here. So I'm going to use a mod operation. So let me just image index equals image index +1 mod 2. What does this do? It means if we're at 0, go to 1. 1 mod 2 is 1. Next time through, we add 1 plus 1 is 2. 2 mod 2 goes back to 0. Then we go to 1 again, and then we try to go to 2, we go back to 0. So it goes 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So if you want to cycle over like all the index values of an array list or an array, sort of without knowing that this is the length of I should actually do that right off the bat, right? Images size here. So that way if we have 3 items, it goes 0, 1, 2, 0, 1, 2. This cycles over all the different legal indices from 0 up to but not including the size. Because that's what the mod does. Okay, so run it again. Well, now we've already, it jumped to the second one. So what's happening here? Here I am changing my window, which is one of the things that causes an event that causes the paint method to be called, which causes paint component to be called, which causes our overridden paint component to be called, which draws the image and moves to the next one. So I can force this to, go from one to the next by making some change to the window. I could have a button that does the same thing, right? I could click the button and I have an action listener, and it would change the index to be the index +1, cycled over the mod, and then it would also have the same behavior. Now, let's say I want to animate this. I want the system to say, go to the next one, go to the next one, go to the next one. Again, I could have a button that does that. But there's also something called the timer, and a timer basically generates an action listener event at some set frequency of time. So I'm going to add a timer to my instance variable, as this panel has to hold inside it this timer that's going to be firing things off. Timer. I need to make a new timer in my constructor. So timer equals a new timer. And here's the thing, I'd say how many milliseconds I want to wait before the next event gets generated, right? So every 100 milliseconds, every 1/10 of a second, this is going to generate an event, and I have to say it belongs to this object. And it doesn't know about timer. Constructor, new timer, constructor timer. This. Oh, okay. So, what's the problem here? This doesn't know how to handle events. So I need it to implement the action listener. So it's part of that larger system. So for the same reason that the paint components work, again, we have to belong to this action listener in order for the timer to be able to work with it. Right? The timer is going to say, hey, call your event action, I should say the name of the actual method, action performed method, then it can work with it. Okay, so timer expects to get something that is part of this inheritance, right? This action listener chain. And so this says, okay, go every 100 milliseconds and call the action performed method. Then you have to tell it to start. There's also a stop kind of thing, right? So you set it up and say how often you want it to go, and then you say go. And it's timer. All right. Now it's going to complain up here and say, hey, you're implementing this interface, action listener, so you should implement action performed. What should happen in here? Every 100 milliseconds, we want to redraw the window. The way to do it is not by me calling paint component. It would do something, but not what we want. What I want to do instead is what we were talking about earlier. I want to request that the system tries to repaint all its components. Then it starts at the top and does everything properly, right? This doesn't happen instantly. This gets put into some sort of queue that says when the overall user interface system is ready to do something, go ahead and do a repaint. And that typically happens like immediately. But if it were caught somewhere, if it's caught somewhere else doing some larger activity, it might take a moment to repaint. All right, well, let's run it and then look at it. Okay, so that is disturbing enough for sure, but it works, right? And that's kind of fun. So we've made a little animated panel that gets signals from the system every 100 milliseconds. Every 100 milliseconds, starting when the thing is constructed, it says create an action event. That goes to action performed. That calls repaint. That goes back to the main system, which eventually goes through everything and says, hey, you should paint your components, which draws the image and moves to the next one. Right? We can make that a lot faster. And, okay, I'm sorry if you're going to cause trouble with that. It's disturbing. And then again, 1,000 milliseconds. This is the same as 1 second, so that should flip every second. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, and so on. All right, pretty cool, right? And again, I could add any number of images through this array list of images to have a more complete animation, although that was exciting enough. Okay, so I think that's the two important concepts here are the idea of how the proper way to live in this larger system of Swing with drawing stuff, and you do it by overriding paint component. And as long as you inherit from something that has a paint component method already, then this will get called at the right time. Then, if you want actions to happen automatically and not just when we do something ourselves, like push a button, for example, a game updates itself at some fast frame per second, then we add a timer. And the timer depends on action listener being in your class. And in there, you could do all sorts of stuff. You could move things around, you update a score, all sorts of things. But fundamentally, at the end of it, you say, now show on the screen all the stuff that I've updated. And you do that by calling this repaint here. And that then eventually calls the paint components. Okay? So, not that much code, which is nice. It's nice I didn't have to figure out how to make my own image. I didn't have to make my own timer. I get to use those things. But you have to kind of buckle down and be willing to accept the right way to do this stuff. And you do that by finding some example and seeing if it works for you. And that's really all there else is to it. And you sort of slowly build up a larger comprehension, I'll say, of how all this stuff fits together. But it really is fitting together from inheritance and polymorphism, where some sort of list of fairly high-level abstract classes are really calling more specialized methods of the specific class. Okay.